Hi and welcome to this lecture on Bayes' rule in Bayes' theorem. Recall that the conditional probability of event A given that event B occurs is given by the following equation. Probability of A given B is equal to the probability of A and B occurring simultaneously divided by the probability of B. Let's call this equation as equation 1. Now let's switch the position of events A and B and calculate the conditional probability of B given A, which is the same as the probability of A and B occurring simultaneously, this time divided by probability of A. Remember that in both equation 1 and equation 2, we assume that probability of A and probability of B are not zero. Then from equation 2, we can find probability of A and B, which is equal to the probability of B given A times the probability of A. Let's call this last equation as equation 3. Inserting probability of A and B, that's the probability of them occurring at the same time, from equation number 3 here into equation 1 there, we get the following. Probability of A given B, which is the left-hand side of the equation in equation number 1, is equal to probability of A and B, which is from 3 equals to probability of B given A times probability of A, divided by probability of B, which is this denominator. Rearranging equation 4, we get the followings. Probability of A given B, which is the left-hand side of the equation, is equal to probability of A, which is this one here, times the probability of B given A, which is this one here, divided by probability of B. This equation number 5 is called or referred to as Bayes' rule. To make the Bayes' rule more clear, let's consider the following example. 50% of rainy days in a certain area start off with clouds. 40% of mornings are cloudy in the same area, and the chance of rain in general is 10%. Calculate the chance of rain later given that the day starts cloudy. Remember that the probability of cloud given it rains is 50%. That is, 50% of rainy days starts with clouds. The probability of cloudy day is 40%. That is, 40% of mornings starts cloudy. The probability of raining in general is 10%. That's the last piece of data that we have. The question is to calculate the probability of raining later in the day if the day starts cloudy. That is the probability of raining given cloudy morning. Applying Bayes' rule, we get the following. Probability of rain given cloud is equal to the probability of rain times the conditional probability of switching these two events, cloud given rain, divided by the probability of cloud. Mapping it back to the Bayes' rule, that's A and B. Cloud is A, rain is A, cloud is B, and so on. We have probability of rain 10%, probability of cloud given rain is 50%, probability of cloud is 40%. Doing this calculation, we end up with 12.5%. That is, the chance of raining later in the day, given the day started with cloud, is 12.5%. The continuation or the generalization of Bayes' rule is Bayes' theorem. Consider two events B1 and B2 such that these two are disjoint. That means they are not occurring simultaneously. And the union of the two gives us the sample space. That means if you put them together, you get the sample space. Then for event A, the probability of A is equal to the probability of A given B1 times probability of B1 plus probability of A given B2 times probability of B2. For proving this theorem, let's visualize this B1, A, and B2. This rectangle represents the sample space. The upper part is the event B1, the lower part is the event B2. You see that B1 and B2 are disjoint. That means they are not having anything in common. There is no intersection between them. On the other side, if you put them together, you get the sample space. And then event A is somewhere in between here. We can write A as the intersection of A and B1, that's the upper part of A here, union A intersection B2, that's the downward here. Remember that A intersection B1, that's the upper part here, intersection A intersection B2, that's the lower part here, is empty set because these two parts are not having anything in common. Therefore, the probability of A is equal to the probability A intersection B1 plus the probability of A intersection B2, because these two events, namely A intersection B1 and A intersection B2, are disjoint. Applying the conditional probability formula on probability of A and B1 and A B2, we get the followings. Probability of A is equal to probability A B1 times probability of B1 plus probability of A B2 times probability of B2. Obviously, we can generalize the Bayes theorem to n events B1, B2 to Bn, such that these events are pairwise disjoint, and the union of all three of them gives us the sample space. Then for event A, the probability of A would be the sum of probability A given Bi times probability of Bi, I from 1 to n. From here, probability of Bi given A is equal to probability of Bi and A divided by this here probability of A Bi times probability of Bi. In the conditional probability of A given B, which is equal to the probability of B given A times probability of A divided by probability of B, which is the Bayes rule, this probability of A given B is called posterior probability. This probability of A here is called prior probability. The probability of B given A is called the likelihood of B if A has occurred. The probability of B alone here is called marginal probability. And this conditional probability of A given B is called posterior probability. And that's kind of the updated probability of A when the information on B is available, compared to the unconditional probability of A where the information from B is not available.